Given the polynomial p of x equals x to the fifth power minus 16x, factor p into linear and irreducible quadratic factors with real coefficients. First, we notice that we can factor out x right away, and so p of x equals x times x to the fourth power minus 16. Check this. X times x to the fourth is x to the fifth. X times negative 16 is negative 16x. We also notice that x to the fourth minus 16 can be rewritten as x squared minus 4 squared. And so this is a difference of two squares. The difference of two squares can be factored using the product of the conjugates. In this case, x squared minus 4 times x squared plus 4. And so x to the fourth minus 16 is x squared minus 4 times x squared plus 4. But we also notice that x squared minus 4 can be rewritten as x squared minus 2 squared. And so it can also be factored as x minus 2 times x plus 2. And so p of x is x times x plus 2 times x minus 2 times x squared plus 4. The factor x squared plus 4 is the sum of two squares. And so we know that it is an irreducible quadratic. For real coefficients, we stop here. This is the factor form of the polynomial using only linear factors, x linear, x plus 2 linear, x minus 2 linear, and an irreducible quadratic factor. Given the same polynomial, p of x equals x to the fifth minus 16x, factor the polynomial completely into linear factors only with complex coefficients. We saw earlier that we can factor p of x using linear and irreducible quadratic factors x, x plus 2, x minus 2, and x squared plus 4. The first three factors are already linear, x, x plus 2, x minus 2, so we can't factor this further. X squared plus 4, using real coefficient only, we cannot factor x squared plus 4 because it is irreducible. However, using complex coefficients, we can still factor any quadratic, irreducible or not. To factor the irreducible quadratic using complex coefficients, we just simply solve for x, whose solutions will be complex numbers. Set x squared plus 4 equals 0, and so we have x squared equals negative 4. We then square root both sides to end up with the square root of x squared equals the square root of negative 4. The square root of x squared, by definition, is the absolute value of x. We rewrite the square root of negative 4 as the square root of negative 1 times 4. The absolute value of x is plus or minus. The square root of negative 1 times 4 is the square root of negative 1 times the square root of 4. The square root of negative 1 by definition is I, and the square root of 4 is 2. And so x equals plus or minus 2i. 2i and negative 2i are the conjugates. And so the polynomial p of x can be factors as x times x plus 2 times x minus 2 times x minus the first complex solution is 2i. The complex zeros is 2i, so x minus 2i. And the second one is negative 2i, so x minus negative 2i is x plus 2i. The complex solution comes in pair. They are the conjugates of each other. Observe that if we were to use the complex coefficients, then a polynomial of degree 5 should have 5 linear factors. The first zero is x equals 0. The second zero is x equals -2. The third zero is x equals 2. The fourth zero is x equals 2i. And the last zero is x equals -2i.